We'll start recording now. So when you open up AutoCAD 2015, you should have a start page, kind of similar to Revit. I haven't really used it before, to be honest. So I just like to go in and to the A up here and create a new file. And it's going to bring up a bunch of templates. The one that we're going to work with is this Autocad template. That's the one that you pretty much should always be opening unless you create your own laser cutting template file, which we'll hopefully get to today. And it'll show up in these templates, which I created one last night, so that's why it's there. So I'm going to start with the Autocad template. And I'm going to close out some of this stuff and just because you don't have it probably. So this is more than likely what you should be opening up to look at. The general layout is, this is the command line for typing in commands here, and these are ribbons similar to Revit in a sense, but it's a little more plain as to what you're drawing. So you have your home tab, your insert tab, annotation tab, parametric. I don't know, I don't think I've ever really gotten into this. I think one class in my associate's degree we used these tools, and I've never looked at it since because they were a pain in the butt. At least I felt they were. Maybe somebody else has a different view. View tab. So we want to click on this layout tab here, and what that does is it brings up a small tab down here that allows us to switch from model space to layout space, which is basically paper space. So this is an 8.5 by 11 sheet of paper. This is a viewport looking at model space. So going back to layout space, this is a viewport that is looking at the model space. You can double click and open up that viewport. As you notice, I scroll in and out. The scale down here changes. Scale of selected viewport. You can make a change similar in Revit where you can change this to whatever viewport scale you want. So if you want to see this viewport as a 1/4 inch equals a foot, it'll make that change in this viewport. In model space, I recommend always drawing 1:1. So, and then only scaling your viewports. If that makes any sense at all. I hope it does. So, in model space, you always want to draw 1:1, and then when you go to print or whatever, you'll print in the layout space through a viewport, and you'll change your viewport scale to whatever scale you want to print from. Does that make sense? Okay. Talking about this options bar down here a little bit, we can change our units to architectural here. This guy next to your scale area here, you can manually minimize the viewport or maximize it. So if I click that, it goes back to model space, but it's not true model space because see, we still have layout 1 highlighted here. So to get to true model space, you actually want to click into model space. Along at the bottom here, we've got This will tell you whether you're in model space or paper space. So as I switch to my layout 1, there we go. That switches to paper space. So I go back to model space, and this shows model space. Down here you have a grid display. So if I deselect, unhighlight this in blue, it takes the grid away. Turn it back on. Snap mode. You can snap to the grids or to polar. I'm not a big fan of this unless you need to snap to these grid lines. Interface constraints I've never used before. The dynamic input, if I like type L in, it starts to give me some headings off to the side about where I am in relationship to XY00, which is this origin right here. Orthographic, if I turn that on, allows me to draw lines at 90 degrees horizontally and vertically from each other. Also, with this on, when you start to draw lines, it gives you the size of line that you're drawing and the angle. So if I turn off my orthographic mode, you can see that I can start to do any angle. And I'm pretty sure if I use the tab button, I can switch back and forth between the angle itself and the dimension size itself. So if you're trying to draw a specific angle of a line, that's fairly convenient. You can set up specified angles here. Pretty sure. Let me type in L, and it locks at that 60 degree, 90 degree, 120 degree. So it starts to, if you want a specific angle to lock at 30, 60, 90, or maybe an oddball, you can select those and it'll lock to those angles as well. This guy right here is on snap basically. So if we turn it off and I type L for line, you could also go back to your home screen and hit line. You'll notice that I no longer have a snap point to snap to an end point or a midpoint. If I turn this on, I can start to snap to the midpoint, end point. And then if you hit this little arrow, you can turn on or off particular snap points. So use it at your will, basically. Sometimes you have a ton of line work and it's snapping to stuff you don't really want it to snap to, and you'll turn it off to draw your line, and then you can use your extend or trim tool to kind of trim the lines up. It really is up to you how you kind of utilize this tool. And this stuff kind of has to do with 3D modeling, which is fairly clunky and ridiculous to do in Autocad. I recommend, if you want to do 3D modeling, do it in Revit. Next, on Thursday, we'll talk about how to actually export from Revit your line work into Autocad for the laser cutter. But today we're basically just going over the basic tool set in Autocad and showing you basically the basic layout, and hopefully create a template file here at the end of class before we get too far. So getting back to the basics here. Settings, I would recommend just leaving it in drafting and annotation. Some of this stuff I'm not even sure what it does. Hardware acceleration, that's kind of a biggie. Similar in Revit, if your graphics card isn't recognized, you may want to turn that off. I'll show you another place where we can change that as well. You can also isolate objects or hide objects. I don't know how to get them back if you hide them yet. I'll let you know. That's kind of new to me. And then this is like full screen. Let me escape out of whatever command I am. So this button takes it full screen and your ribbons go away. That button allows you to get back to your ribbon. Quick access toolbar here, similar to Revit. This is your label tab again. So if I turn it off, the labels go away down here. If you're ever curious about where a command is and you can't find it on here, typically you can type it in and it'll start to tell you what kind of commands it has. So for instance, like line, if I start to type it in, it'll give me a bunch of stuff, but I'm looking for line type. So if you're like in another, I don't know, screen and that's the lines aren't there to utilize, you can always type the command in. Trim, fillet, array, rotate, mirror, scale, copy, and move are all similar to Revit's commands, except for the trim and extend tool. Revit kind of has condensed those two into one action, which may have confused some people, but here they're two separate commands. So if I were to type L and enter, and let's take this stuff off because it drives me crazy, leave orthographic on, and escape out of the command, and I want to connect these two lines together, you can type in extend, which is the same as going up to your toolbar and clicking extend. All right. And if I hit enter again, see I canceled out of the command, but if I hit enter, it'll go back to whatever your last command was, which was I drew a line. So I need to type back in extend again, and now it kind of gives me a command line to select the object that I want to extend to, and then press enter, and then hover over the other line and it extends to that line. And if I type in trim, I can trim to this line, hit enter, and then take that away, and so I can make a 90-degree angle. I'm going to hit Control Z. The other thing that you can do is type in fillet, which you'll also find up here. So there's fillet, chamfer, and some bending curves. If I type in fillet and enter, where am I going here? You can start to select different types and of what you want to do, but if I just wanted to quickly trim these two up, type fillet in and I select one and then the other, and it creates a 90-degree fillet. You can also put in a specific dimension and have it cut off at a certain angle, or a certain radius, sorry, for fillet. Fillets are radiuses, chamfers are straight lines. So you can get to tools through typing in here. You can also go up to your ribbon to draw. Okay, polylines are a little bit different than regular lines. They basically are a series of lines, and if I press enter, this is all one line. See how that became one line? When you hover over like a midpoint, you can like convert that to an arc, and start to change this line a little bit easier. But if you right click, you end up getting, you know, some commands here that aren't really necessary. So it's just hovering over it, and you can say stretch this vertex maybe, or add a vertex in here to create another one of these so that you can create more arcs. So this is how you kind of create a continuous line that sometimes it's necessary, like doing contour lines. It's, you know, like when you go into landscape architecture and they ask you to make contour lines. I don't know if any of you guys are interested in that, but they'll get on you about whether or not you're using the line splines versus polylines. Splines don't do true arcs, whereas polylines do. So there's certain reasons to use polylines, and there's certain reasons to use splines. And splines are, where did I find those guys? Just a second ago. Are they calling it bond curve now? I don't know. No, they're not. That's why I like knowing the different. My orthographic is on, but basically that's a spline. And I hit enter, and I select this thing. And this one's not too bad, but it breaks it up into, or no, it is one continuous line, right? Versus, I don't know. They're both continuous.
Yes,
Yeah.
but this is the first time I've ever seen the control points actually on the line. I'm wondering if they changed this line parameters.
Yeah, I remember them being out here, and you
Because
could
you
stretch
just-
them a little bit.
There was all kinds of problems because you'd import them into other programs and they wouldn't recognize lines correctly, so you always did a P edit.
Yeah, so that might have
fixed
changed
that.
stuff.
Hopefully it did.
So another great tool is P-Edit, he just mentioned. If you had a series of lines that you wanted to change into a polyline, so maybe for laser cutting, you don't want the laser to stop and start a bunch of times, you just want a continuous line, but you've drawn lines, right? So we've got two separate lines here that aren't connected, so the laser cutter will cut this line, stop, then cut that line. We can type in P-Edit and select multiple, and then select these two lines and press enter, and we want to, yes, make them polylines, and then we can join them, typing J in and escape, and now it's a polyline. So you don't necessarily always have to be drawing in polyline to create a polyline. So many blank stares right now, it's great.
You're lost.
Yeah, I'm diving in a little bit, but just kind of giving you an idea of how to draw line work. All right, so let's back up. Let's digress a little bit. And a couple other key things that I like to have up on my screen. You obviously have layer properties here, but to me, this is kind of an awkward kind of layout. I don't really like the way this looks. If you type in layer, it brings up a dialog box here that you can just sit off to the side of your screen, and it disappears when you go back into your model space. But this is a really intuitive way to create new layers in AutoCAD. So creating a new layer, name it, and you can change stuff really easily here. Just for the heck of it, let's make a bunch of layers. So
You want to explain what a layer is? I don't think you told me.
why don't you explain what a layer is?
I'm not teaching you.
Mr. Smartass. Basically, layers are similar, in my understanding of it, layers are similar to categories, right, in Revit. So every layer, you can hide it, you can unhide it, you can put whatever lines you create onto a specific layer and turn them on and off. You can freeze them. You can tell it not to print that specific layer. And there's different options. You also can change the line type. So right now it's kind of standard. We have a continuous line type. I can load in pretty much any line type you want in here. And so, if you want to show a center line, you would create a center line layer and put all your center lines on that layer, and that line type would come up. It's tough to kind of get into this hardcore because you could talk about an entire hour of just layers and line work, and we really don't have enough time, unfortunately. The simplicity of it is that we're going to create continuous layers in order to laser cut, and we're going to change our color type to match our layer template here for laser cutting. So you can find this in the wood shop. You can also find it on Blackboard. So there's raster engraving, vector cutting, and there's different depths that it cuts at. And so basically we want to set up the layers for laser cutting. And so vector engraving, the color of it, we're only going to use these colors down here, and I'm going to choose red, click OK, and also the line type to 0, 0. I'm going to create a new layer, and notice it duplicated basically the raster engraving layer with all its settings. So whatever you have highlighted, when you click a new layer, it kind of duplicates it but allows you to rename it. So so this one we're going to name raster engraving deep, and we're going to change it to green. You can also hit this little button to keep it open all the time. It's this little button right here, so it doesn't disappear. And I want to right click this and rename it actually, so that we have light. And I'm going to duplicate that again, and we're going to go vector engraving light. I'm going to change my color to yellow. Click OK. And we're still continuous with a 0 line weight. Let me create another layer. And vector engraving. Deep. Thanks, Ryan. Appreciate that. And select the blue, not the cyan, but the blue. Click OK. And I'm going to create another layer. And we're at vector cutting. And we're going to go interior. And we're going to set that up as magenta. Click OK. And one more. Vector cutting exterior. And that's going to be our cyan color, which is the light blue. So basically, if you're cutting, creating an exterior cut, so if you have a wall here, let's just continue this all the way around. I'm going to click my ortho button on. And so let's just say that that's our exterior wall, or a wall that's, we can select, yeah, okay. Next little bar that we want up here is properties. So if I type in properties, I will get another toolbar here. And so when I select on a line and hover over properties, I can chart to change what layer this line is on. And so you see as I scroll over, it starts to change color. And so we are looking at vector cutting exterior. So I brought this window up by typing properties into my taskbar here to get this to come up. And so you basically want, whoops, let's cancel that. You want your line type to read by layer. You want your line weight to read by layer. And your color by layer. So we could, even though it's on our vector cutting layer, you could accidentally hit yellow, and now you go down to the wood shop and this is going to read funny as basically a vector engraving line. So you want to be careful that you want the color type to be by layer, your line type to be by layer, and your line weight to be by layer. And we can select multiple lines at the same time, and you can start to see, oh, layer varies, and so we're going to put those on the same layer, and the color by layer, line weight by layer, line type by layer, line weight by layer. So if you were like making floor plans and stuff in Autocad, you would start to change your line weights. You would create new layers probably in a separate file. This will be like a template file that we'll use, that you'll always use for laser cutting. But if you were to draw your floor plans in Autocad or your sections in Autocad, you would want to start to change your line weights to being heavier line weights based upon your depth of your floor plan or section. But for now, we're just going to leave them at 0, 0 so that that's what the laser cut settings are. So now that we kind of have these layers set up, let's go ahead and create an actual template file that we can open up, and these layers are already in here and set so that we don't have to recreate this thing again. So if I type in plotter manager, it should bring up this dialog box here. And basically we want to right click DWG to PDF and copy it, and then right click again and paste it into this same window. So we're basically in we're in the place where AutoCAD looks for its template files when it goes to print. So we want to rename this DWG to PDF and laser cutting. I'm just going to make mine 2 because I already have one in here. And we don't have to click save or anything because we were literally copying a file and renaming it. I'm going to close this down. I take that back. We're going to open it back up. I've actually never created a this is the second time I've ever created a template file, and it's really nice. Plotter manager. And I'm going to open up this file, DWG to PDF laser cutting 2. And under device and document settings, we want to select custom paper size. And so what we're now doing is creating our custom paper sizes. So you could theoretically create 11 by 17 paper size. You could create Arc E, but you don't necessarily have to, because when you go to plot, it already has those paper sizes in there. But you could theoretically create your own custom paper sheet sizes. What we're doing is we're creating custom paper sheets for the laser cutter. So there's 2 laser cutters. There's one that is 18 by 24 inches, and the other one is 18 by 32 inches. So I'm going to click add, and we want to start from scratch and click next. And so our width, we're going to make this one 32 inches and our height 18 inches, and definitely inches as our units, and click next. And we want a margin on here because the laser cutter won't print or won't cut anything that's closer to 0.25 of an inch, like a quarter of an inch. from the margin. So we want to go ahead and leave our margin, our dashed line margin at 0.25 of an inch. Click next. And at this point we can name the paper size to be laser cutting 18 by 32. Click next. And we want to leave this file name the same. Click next and finish. And so now we have a template basically. So when we go into our paper space, our layout space, we can define this layout space to be this 18 by 32 paper space. We're going to add one more, and we're going to do 24 by 18 and click next and next and rename this laser cutting 18 by 24. Next. Did I do that right? I feel like I got ahead of myself there and was renaming the file name, which it just skips because, yeah, I don't have an explanation for that. So, hit the finish and repeat for the 18 by 24. So we can click OK and escape out of this, and now we can select our layout 1. We can right click it and go to Page Setup Manager, and we want to create a new page layout, I think. Cancel, cancel, cancel. Sorry, modify. We want to modify layout 1. There we go. And under the print name, we should find our laser cutting, labeled my file 2. You guys should probably just have lasercutting.pc3. That's the name, the plotter name. And the paper size, if we scroll up, we should see laser cutting 18 by 24 and laser cutting 18 by 32. So I'm going to select the 18 by 32, and I'm going to change my plotter area to extends. And as you can see a little picture of what's going on here, I want to center the plot. And you'll see that puts it in the center. Basically, that's like the viewport outline. And we want this plotter scale to be 1:1. And we're going to click OK and close. And you'll now see that, let me minimize this. We have a paper space here that changed from 8.5 by 11 to our 18 by 32 size. So similar, if anybody's ever laser cut it in the past, Jay has a template file that looks exactly like this that's preset. Whenever he goes into your file, he switches it to this and then zooms in on, he asks you what scale you want, and it zooms in. So you always in model space are drawing 1:1, and then in your layout space you'll specify by selecting the viewport what scale you want to print at. So maybe you want 1/16 of an inch equals a foot, and it'll change. It's very hard to see because those lines are like 2 feet by 1 foot or whatever, but all those lines are now scaled at 1 inch, 1/16 of an inch equals a foot. And in order to scale this viewport up, you can select it and drag out. If you have your orthographic on, it's only going to allow you to move horizontally and vertically with those lines. So you can change your viewport to being the size that you want to see. If you don't have a viewport for some reason, if you type in viewport, it brings up a dialog box where you can select a single viewport or 2 or 3 and create multiple viewports to print. If you just utilize Autocad for laser cutting, you probably won't need to do this, but it's good to know that it's there. So that's one. Let's click on layout 2 and let's change that one to our 18 by 24 inch. So I right clicked on our layout 2, close this, right clicked on layout 2 and went to page setup manager, and I want to modify layout 2. And again, we're going to select our DWG to PDF laser cut 2 as our print plotter name, and our paper size is now going to be 18 by 24. Our plot area is going to be the extends, and we want to center the plot, and we want it 1:1. And again, we can move our viewport so that it encompasses the area that the laser cutter will print. Oops. If you scroll in, you can get a little more exact too. So you can start to really hone in on that corner. So we want to go back to our model space and probably delete. So if I type in E for erase and enter, I can click and drag over all that and delete it with the enter button. We have our layers set up here. We have our layouts set up for the different sizes. Now all we need to do is save this file as a template file so that you can open it up every time to get this thing in. So let's go up to File, Save, or Save As. Now just click Save. And under the file type, we can scroll down to what's called an AutoCAD drawing template. And if you select it, it'll automatically navigate to the template files area where it looks for template files. And we can just click on the ACAD and put in a dash mark and type in laser cutting template. I'm going to name mine 2 because I already have one, and click save. And save all layers as, yeah, we want to do what it says here. Click OK. So I went ahead and saved this, and so if I just go ahead and close it out and go File, New, you can see my laser cut template file here, and I can open that back up, and I have all my layers set up correctly, continuous line types and line weights, and the colors are appropriate, and the names are appropriate. So next class I'm going to dive in a little bit more into the functions here of AutoCAD, but next class we'll export one of our views from our in-class assignment 5, like our east elevation. I'll show you how to isolate and hide, isolate whatever you want to cut out, so like the exterior wall, you know, I'll show you how to do that and export that and then import it into AutoCAD, and we'll go through some kind of techniques about how to explode it, because it comes in as a block, and explode it and change it so that we can just copy and paste it into our template file, and then change the layers of the lines appropriately to go laser cut. If that makes some sense. And I get the okay look from Ryan, which is always a good sign. He's falling asleep. So, diving into AutoCAD a little bit further. Yeah. We've got our layer properties manager here, our properties themselves. The other one that I like to have up is external references. Where'd you go? There he is. This is nice if you ever need to like load an image or another DWG file into this file to trace or reference. This is a really great tool to utilize, and it kind of just helps to keep track of what they are. So similar to like importing an image like in Revit, where we can reference it off that viewport, it's kind of similar in that way. So if you have an image that you need to reference, you can do that. The only downside to it is that it's a reference file, so it's an external file somewhere that it's looking at, and so you don't have as much capability as you would if you just inserted it into the file itself. But it's a good reference thing. So if you want an image that you want to reference, maybe it's an image that you create and then you want to have laser cut out, right? You can start to trace over it to get the line work of the image in order to utilize it in laser cutting. Yes?
So if you import it, you can scale it and 3D and things like that?
Yeah, yes. You should be able to utilize these tools here to do whatever you want with the image, but you can't explode it. So it comes in as a block, like basically kind of similar to a component, right? You can't make any changes to that component without going back into the family to make those changes, right? So it's similar in that respect. But if you import, so there's two different ways of bringing it in. One is through X references, and another is through what's called import. If you import it, then you can explode it and become separate line work. But generally, when you're importing, you're just importing another DWG file that has line work in it. Whereas this allows you to bring in an image that you can trace over or use as a reference file. And yes, you can scale it. But typically in model space, you really want to just stay drawing full scale, 1:1, and then change your viewport to the scale that you want to print out at, which is a little counterintuitive. For a long time, I would actually take my stuff in, like anything that I was cutting out in the laser cutter, I would import 1:1 into model space and then manually scale it down to whatever size I wanted, so I could put it on a 18 by 24, 18 by 32 sheet and kind of set up multiple sheets. And then use my viewport as 1:1. It's kind of like totally opposite, and when you start to think about it, it's like, why would you ever do that? But I always found that this scale button never worked in the earlier versions very well. And I was kind of taught the old school way. They didn't have the ribbon and all this stuff when we first started, so like everything was command line. And like, so it's just a different way of utilizing the software. So customization a little bit. If we type in options, it is the same thing as going up to here and clicking options. Found that out yesterday too. I went, oh, that button's nice. So, we can change our scheme, right, to being light, right? Now it's really starting to look like Revit. We can change our background color, display color. In 2D model space, we can change the color to being like white. If you like white, I can't stand white. But you can make it whatever color you want. Layout elements, this is where, let's just cancel out of this and go into layout space and go back to our options. This display printer area, if we uncheck that and hit apply, our little dashed line goes away. And if we click display paper background and uncheck that and hit apply, our paper size goes away. So if you just want to set up a viewport that's a specific size and print that off without having to deal with a paper size, which is how I learned how to do this, you can remove those options. I would suggest probably leaving them on, but it's nice to know that they're there and you can make that change. You can start to affect the smoothness of arcs, segments of polylines. I don't know, this stuff is pretty standard. You probably don't want to manipulate it, but it's good to know that you can. You can change your open and save options. I really wouldn't mess with it. There's no need to, but you could basically say, well, I want to always save it to a different type of file if you wanted to. But it kind of back saves to this 2010 template file so that you know, a lot of firms don't upgrade their AutoCAD. They kind of buy like version 2010, and then 3 years later it's not really out of date 'cause you can still use it. But if someone else like that they're working with is using a newer version, you can start to back save your version so that other people can open up the file, which is nice. Revit doesn't allow you to do that. They make you buy the next version because they want that money. At any rate, plot and publishing, you can set up a default plotter, whether that's, you know, a PDF writer or a specific printer in Studio. You can set that up there. Graphic performance is this button here to turn on and off hardware acceleration. So that's under your system uses. So you can turn that on or off. I leave mine off because it doesn't recognize my my video card as being compatible. You can customize your user preferences here, keyboard entry, keystrokes, block editor settings. I mean, this kind of stuff is diving pretty deep into the software, making changes, but you're more than welcome to experiment with it. So if you want to, I believe, you know, create more line types. Actually, it doesn't appear to be a way to create more line types, but you can auto display, you know, a thicker line versus a smaller line. You could change this from millimeters to inches if yours is reading millimeters right now. So that just changes how it's being read. I don't know, most cut lines. Yeah.
Where's the units tab to like change your units?
That is actually under a different setting. It's not under the options tab.
Where would it be?
If you type in units,
Oh, okay.
you can change your units. I was going to get to that in a minute here. You jumped the gun on me. It's all right. Drafting, 3D modeling, probably won't mess with this stuff. But at any rate, you can dive pretty far into customizing your settings. Drink some more coffee there, Ryan. So I'm just going to hit cancel. But if you make any changes to your display or options, you want to hit apply before you close. You type in units. This brings up your scale, your units. So you want to be in architectural. Your precision, probably a 1/16 of an inch is where you want to be. And for angles, you definitely want to be in decimal degrees. Precision, you can go, you know, if you're doing something that needs, you know, this much precision. You know, if you're making a machine part or something like that, and you're taking it to get water jetted or something, and it needs like to be a, what is this, 10,000th of an inch, you know, you can start to get precision. And this is where you can change your scale of whether you're reading in feet, inches, centimeters, millimeters. I don't even know what half of these are. Just leave it in inches, because when you, it doesn't, like when you type in a distance, you're pretty much always typing in inches unless you specify with a tick mark that it's feet. You know, like shorthand, like 5 feet with a little whatever they're called, little tick mark, little colon or whatever it is. What's that thing? Apostrophe. I think English was not my first language. Little apostrophe. At any rate, so let's go back into model space and let's just play around with drawing some shapes. Can start to draw lines. And so if you're on snap is on and you're not quite centered, it's going to put it at an angle. If you want to you can go past it and then use the fillet tool to fillet that. If you want a specific distance, you can start typing in maybe 20 feet, hit enter. Let's see what that gave me. Probably gave me like a 20-inch line. So I go to my annotation and dimension. And scroll in here. 240. What the heck is that, right? I don't know. If we go to here and select Manage Dim Styles, we can start to modify or create a new dimension style. And let's just say copy of standard for now and hit continue. This allows you to change your dimensions. So primary units, you want to change that to architecture and your precision 1/16 of an inch. And so you'll start to read these types of dimensions. And fit scale for dimension features. If you start to change this, so it's basically, if you want it to read like a 1/4 inch equals a foot, you type in 48 because 12 times 4 is 48. And click OK. And close. And now when we draw a dimension with that, hopefully it doesn't shoot me in the leg. It now sizes that a lot bigger, and it also is reading that it's 20 feet, right? So if you're needing to dimension something, I'd recommend creating your own dimension style, and you can modify it after the fact and just change your primary units to architectural and the precision to 1/16 of an inch. And the fit, if you want to read larger numbers, under the scale for dimension feature, you can type in manually what size you want that to read. So that's a 1/4 inch, basically equals a foot. 96, right, is 12 times 8. It's 1/8 of an inch equals a foot. Sometimes that can get a little wonky when you start to look in your layout. So if I look in my layout and I change my scale of my viewport to being 1/4 of an inch, sorry. You know, the legibility of that's pretty clear. So it's kind of, let's see if we make one that's, let's create a new one and just do copy to and play around with this and say this is 96. Click OK, close. Let's go back to our model space And let's just drag out one more dimension here of this line. The little mouse wheel pans, by the way. It's kind of useful. So you can see that that's twice as big, basically. If we go back to our layout space and change our viewport to being 1/8 of an inch equals a foot. You can see the difference in the size of these. So typically, whatever your viewport's set at is kind of the size of the letter, or of your dimension size you want it to be. So probably never, I don't know if you'll ever utilize this or not, but it's just kind of helpful hint about dimensions. So if we draw a regular circle, it's based off of our diameter down here. It's gray. So if we type in
Drawing a radius right now. If you want to draw a diameter, you have to hit D.
You're right. So it says specify radius of circle. If I want to specify the diameter, I would type D first and then enter. And now I'm drawing in diameter. Or if you want to go back to radius, you can type R, and that changes how you type in the information and how you get out of the circle. So if I type in 5 feet, it creates a radius of 2.6 because I was in diameter. The other kind of cool thing with a circle is you can put on two tangent lines. So I can click on this line and type in a specific radius. Let's just leave it at 2.6 and press enter. You'll start to create an arc here with the tangent points of the circle being exactly on these two lines. So if you're ever doing line work where you need to kind of specifically make a circle that hits the tangent, or that a line hits the tangent of a circle, and trim that up so that it's a perfect arc, you can do that as well using your trim and extend tools. Can also utilize all these different ways to create an arc. So that's really the basics of AutoCAD. And again, if you want to start changing the layer that you're on, you can do that in your properties under layer. So if you're drawing multiple stuff and you only want to see one element, you can put that on one specific layer, and you can start to turn those layers on and off here with the light bulb. So we have layer 0 on. We can it's giving me a warning sign because that little check button is saying that's the layer that we're drawing on, and so I can turn off that layer and all those lines disappear. You can turn it back on. If you ever find yourself accidentally clicking this freeze layer, that will prevent you from working on that layer or doing anything with that. You can turn off layers to be printed or not. And if you want to like match a layer, so say we put this layer or that guy on a roster layer, and we want to match a layer. and we want it back on the white layer. You can see that that did that. And click it the other way around. Oops. At any rate, I'm not too fluent with this, as you can tell. But these same options here, you can also match properties. So if you have lines that are specific properties that you've laid out here, you can use the match property tools to match those properties to another line that you've made, stuff like that. So those are the basics. Next Thursday we'll talk about exporting an elevation view, importing into AutoCAD, and actually utilizing this file that we created.
Does anyone need a sign-in sheet?
Usually it's not like.